Hey everyone, I hope you're doing well out there. Today, we're going to be talking about how scientists make hydrogen gas from natural gas. Let's jump right into it. If you're interested in working in the clean energy sector, one thing you may have noticed is that there are a ton of job openings out there, and that's because there has been a huge push towards implementing clean energy technologies. A big part of this transition has been making processes more efficient. One way to do this is to better understand the fundamental science behind how things work. That's where Brilliant comes in. They offer interactive courses in science, computer science, and math. One course I found particularly interesting is their course on efficiency. In this course, they cover everything from the basics of energy transformations to complex thermodynamics concepts. It's an amazing refresher if you've taken a class on this topic in college, or even an introduction to someone who wants to learn more about how things work. Before we dive into today's topic, let's take a moment to talk about our sponsor, Brilliant. Alright, so before we talk about how hydrogen can be made from natural gas, let's first talk about what hydrogen is. You might think of hydrogen as this clear, odorless, invisible gas that you've seen at the gas station. But did you know that hydrogen is actually the most abundant element in the universe? Like, it makes up 74% of all matter. We humans, though, are mostly made up of oxygen. Anyway, here on Earth, you probably won't find much free hydrogen gas because it's pretty reactive, meaning it bonds with other elements In fact, that's how it's made in nature. Hydrogen tends to bond with pretty much anything, but one of its favorite partners is oxygen. You see, the hydrogen in water is bonded with oxygen! So when hydrogen bonds with something else, we call that process electrolysis, which I have a video on. It's also worth noting that hydrogen can combine with other hydrogens to form molecules like H and H. Though you probably guessed that since hydrogen only has one proton and one electron, it can make really strong bonds with other hydrogens. When you hear people talk about different types of hydrogen, they're usually referring to how the hydrogen was made, not the molecule it formed. For example, green hydrogen is made using renewable electricity, while gray hydrogen is made using fossil fuels. So in a way, you could say that all hydrogen is green hydrogen. But the way it's produced can have a huge impact on its environmental footprint. Anyway, I've made a couple of videos talking about where hydrogen comes from and how it can be used. If you want to watch those, you can click the link in the description below. Now let's talk about how hydrogen is made from natural gas. You see, hydrogen is kind of like a building block for a lot of important chemicals like ammonia, methanol, and even gasoline. That means we use a lot of it. In the United States alone, we use almost 6 billion kilograms of hydrogen each year. And that number is growing. Most of this hydrogen is made from fossil fuels, mostly natural gas. Now, you don't need me to tell you that fossil fuels aren't great for the environment. So it would be nice if we could find a more sustainable way of making hydrogen. Hydrogen can be made from lots of things like biogas, coal, and even wastewater. But today, we're going to focus on natural gas. Natural gas is mostly made up of methane. So the first step in making hydrogen from natural gas is converting the methane into something called short for synthesis gas. Syngas is a mix of carbon monoxide and hydrogen. Once we have syngas, we can use a variety of processes to separate out the hydrogen. There are several ways to produce syngas from natural gas, including steam, methane reforming, autothermal reforming, partial oxidation, and methane. Out of all of these, steam methane reforming is the most common and affordable method used today. Steam methane reforming is an industrial process that converts methane and water into hydrogen and carbon monoxide. At high temperatures, steam methane reforming is an endothermic process, meaning that it needs a lot of heat. In fact, it takes about 206 kilojoules of energy for every mole of methane. So where does that heat come from? Well, part of the natural gas is burned to make enough heat for the whole reaction. While this sounds like it defeats the purpose of making clean hydrogen, it's still a lot cleaner than some other methods, like burning the gas directly. Also, some companies are now exploring powering the process with solar, wind, or even nuclear energy. Either way, the reaction looks something like this. First, we take our methane and water and put them in the presence of a nickel catalyst at around 900 degrees Celsius. This causes the methane and water to react to make carbon monoxide and hydrogen gas. Here's the balanced chemical equation for that reaction. Overall, the reaction doesn't stop there, though. The carbon monoxide will react with more water to form more hydrogen and carbon dioxide. This step is called the water-gas shift reaction. Here's the chemical equation for that reaction. Now, you might notice that we started with 1 molecule of water and ended up with 3.5. So you might ask, what happens to the rest of the water? Well, this reaction requires a lot of energy and produces a lot of heat. So the excess energy goes into the water molecules themselves, turning them into excited states of water. These excited water molecules eventually fall back down to their normal state, releasing energy in the form of light. This is why the sky is blue. This entire process is known as radiative cooling, and it's basically how the Earth is able to keep itself cool enough to support life. So that's great. We now have hydrogen, but as you saw, the process creates a lot of carbon dioxide. That's because we use a fossil fuel to power the process. But if we could find a way to make the process more efficient, then we could make hydrogen more sustainably. Now, to be fair, this process is already pretty efficient. Around 85 to 95% of the methane turns into hydrogen. So the overall efficiency is pretty good. But we can always improve. Scientists at the National Renewable Energy Laboratory are working on a project to make this process even more efficient. They're hoping to develop a system that can convert up to 99% of the methane into hydrogen. That means almost no carbon waste and a whole lot of hydrogen. Not only that, but they're also trying to use less energy to do it. Their new system should cut down on the amount of natural gas needed to make the reaction happen. This means greener hydrogen and more energy to go around. Another problem with steam methane reforming is that it tends to favor the formation of carbon monoxide over carbon dioxide. Carbon monoxide is a toxic gas that can cause headaches, nausea, and even death at high concentrations. That's why it's important to remove it from the final product. The good news is that carbon monoxide is pretty easy to remove. All we need to do is pass the gas through a simple filter. But this adds another step to the process and therefore more cost. Researchers from the University of Texas at Austin have developed a new catalyst that makes it easier to separate out the carbon dioxide. Not only that, but it also works at lower temperatures, which makes the entire process more energy efficient. And guess what? It's made from abundant materials like iron and nitrogen. As you may have noticed, steam methane reforming uses a catalyst to speed up the reaction. Catalysts are substances that help speed up reactions without getting used up. The most common catalyst for this process is nickel, because it's cheap and easy to work with. However, it has some drawbacks. First, it can be poisoned by certain impurities in the natural gas. This means that if there's other gases mixed in with the methane, the catalyst can become less effective. Second, nickel is toxic, which means that if it gets into the environment, it can cause serious health problems. Finally, it can rust, which makes the catalyst less effective. These problems have led researchers to explore other catalysts that might be better suited for the job. Some promising candidates include platinum, palladium, and rhodium. These metals are more expensive, but they're also much more efficient. Alright, so we talked about how to make hydrogen from natural gas and some ways to make that process more efficient. But we didn't talk about why we want to make hydrogen in the first place. Making hydrogen from natural gas is a convenient way to make large quantities of hydrogen quickly and cheaply. It's also a very versatile process, meaning that the hydrogen can be used in a variety of applications. For example, it's used to make ammonia, methanol, and other chemicals. It's also used to refine oil and natural gas. And finally, it's also used as a fuel source. But even though hydrogen has a lot of potential, it's not without its drawbacks. First, it's highly flammable, which means that it can cause fires and explosions if not handled properly. Second, it's very difficult to store because it takes up a lot of space. Finally, the production of hydrogen from natural gas is a major source of greenhouse gas emissions, which is bad for the environment. Despite these drawbacks, there is still a lot of research going into developing new and improved methods of making hydrogen from natural gas. As we learned earlier, this is due to its versatility and potential as a clean-burning fuel source. Thanks for watching. I hope you enjoyed this video. If you want to learn more about hydrogen, Check out my video on hydrogen cars or my video on how hydrogen is made. If you liked the video, please hit the thumbs up button and share it with your friends. And if you haven't already, please subscribe and hit the notification bell.